Alright, welcome back guys. We're going to look at 5B, and you can see it's titled, Should You Believe a Statistical Study? So what we're going to be looking at are things to consider, okay, when you look at a statistical study, if you do, or when you hear the results of some statistical study. Okay, I hear all the time on the news, a new study shows that drinking 2 cups of coffee every day will reduce your risk for a heart attack by 20%. Okay, you hear things like that constantly. And so we want to be wise consumers of information and not necessarily go out and start drinking all kinds of coffee, So anyway, all right. So, a lot of this I'm just going to kind of be reading and talking about, but I did put some links in Blackboard for you to look at. So here, this is a link to a video. It gives some examples in which you could potentially draw an incorrect conclusion from statistical studies or from the results that statistical studies claim to show. Okay, so you can watch that video, but I'm going to dive in right here. It says 8 guidelines for evaluating a statistical study, and we're going to look at each of these in a little more detail. The first one says get a big picture view of the study. And it says you should understand the goal of the study, the population that was under study, and whether the study was observational or an experiment. Okay, and we've talked about the difference between an experiment versus an observational study. Okay, we've also talked about population. Okay, we take a sample, and from that sample we make inferences about the population, but we want that sample to be representative of the population. Number 2 says consider the source. This is a big one here, guys. Look for potential sources of bias on the part of the researchers. Okay, again, we're going to talk about this here in a minute. Number 3, look for bias in the sample. Decide whether the sampling method was likely to produce a representative sample. So we talked about that in 5A. There's a whole science or literature about sampling methodologies, okay, because our goal is to have our sample approximate the population as much as possible. And then number 4, look for problems in defining or measuring the variables of interest. Okay? Ambiguity in the variables can make it difficult to interpret reported results. There's an example that we'll look at here in a minute. So if you're trying to measure, something like love or satisfaction or things of that nature, those can be ambiguous. So you have to be careful. You have to really concretely define these variables. In the world of education, we think about, or we talk about, how do we measure a student's understanding in a course, okay, or a student's understanding of material or the concepts in a course. Well, one way we try to do that is by giving exams, giving homework, things of that nature. But when we start listing the learning outcomes, it's not a good idea to say the student will understand whatever, okay? Because then we need to define, well, what does it mean to understand? How can we measure whether a student has actually understood that or not, okay? And so we have to be more specific when we're making these learning outcomes. They have to be things that we can actually measure. So anyway, number 5, beware of confounding variables. And we'll talk about this. It says if the study neglected potential confounding variables, then its results may not be valid. So these are basically other variables that can influence the outcome of the study. Okay, things that you might not consider. Number 6, consider the setting and wording in surveys. This is very crucial. Both the setting and wording in surveys, guys, can elicit completely different responses. It says, look for anything that might tend to produce inaccurate or dishonest responses. So we'll talk about the wording in surveys and how that can yield completely different responses. You know, words have power. The way we put those words together, it has power as well. It's very influential in how we understand ideas. Number 7, check that the results are presented fairly. Check whether the study supports the conclusions that are presented in the media. Okay. And then number 8, stand back and consider the conclusions. Evaluate whether the study achieved its goals, and if so, do the conclusions make sense or have practical significance. Okay. All right, so let's go to number 1. Guideline number 1, get a big picture view of the study. So what's the goal of the study? Okay, what's it trying to prove or establish? What was the population under study? Okay, was it the population of students at a particular college? Was it the population of students 65 or older at a particular college? Was it a population of a specific species of fish in this specific lake? Okay. We have to be very clear about what our population is. Was the study observational or experimental? Okay. If it was an experiment, was it double blind? Was it single blind? And remember that a double blind study is going to be the most powerful. Okay. And then what were the treatment and control groups? And were they properly randomized? Okay, these are all important things that can, if these things are not done properly, a study can yield results that are not accurate at all. And then given the goal of the study, was the type of study appropriate? Okay. So just some questions to be asking yourself, or to be sort of on the lookout for. Okay. And then guideline number 2 here, consider the source, and this is a big one. Okay. Who's actually conducting the study? So here's a question. Is smoking safe? Now, probably most people today, anyway, would agree that smoking is not safe. But that wasn't always the case. And you'll see why. It says, for years, according to the tobacco companies, there were no dangers associated with smoking. Okay? Years ago, guys, you would see ads on TV with celebrities smoking, and these very attractive, well-dressed individuals that it had all these desired characteristics, and they were smoking, and so the public was made to believe that there was something very attractive and very cool about smoking. And that was created by these tobacco companies. They painted a false narrative. These tobacco companies, they refer to studies done by the Tobacco Research Institute, which was actually funded by the tobacco companies. Okay, so here you had a conflict of interest, and many times in studies there may be a conflict of interest. Okay, and it says, by the way, after decades of arguing to the contrary, in 1999, the Philip Morris Company, which was the world's largest seller of tobacco products, publicly acknowledged that smoking causes lung cancer, heart disease, emphysema, and other serious diseases. Okay, so basically this was known by the tobacco companies for a long time, but they had this entity that was essentially under their control. It wasn't really a third party conducting all these studies, and they were saying that, well, smoking, it really wasn't bad. Okay, and so that's why, like in the world of pharmaceuticals or anything related to our health or things of that nature, it's good to have these third-party entities that have no vested interest in the outcome of the study. That's how you get the most objective results. Okay, and unfortunately, guys, a lot of the pharmaceutical companies, they do their own testing, and that's one of the reasons that we need things like the Food and Drug Administration. Now, they're not supposed to be biased or have a vested interest, and you could say, well, ideally they don't, but that may not necessarily be true, because politics and money can really change a person's motivation. Okay, but anyway, that's kind of the idea behind having a governmental agency like the Food and Drug Administration. It's supposed to be this outside entity that can test and study these things without an agenda. But anyway, let's go to guideline number 3. Look for bias in the sample. Okay. So there's 2 different types we're going to talk about here. Bias in choosing a sample. So something called selection bias occurs whenever researchers select their sample in a way that would tend to make it unrepresentative of the population. So, for example, a pre-election poll that surveys only registered Republicans has selection bias because it is unlikely to reflect the opinions of all voters. Right? And this sometime, this has been evidenced in some of these political polling. I think I mentioned this previously. If all these political polls are only conducted in urban areas, because that's easy, it's easier to find people to poll or survey because the population densities are higher, and they may not give us the best results, or those samples may not be all that representative of the population because not everybody lives in an urban area. And then the second one here is participation bias. Occurs whenever people get to choose whether to participate. So, for example, if participants must take action to participate in a survey rather than being selected at random, those who feel more strongly about the survey issue are more likely to participate. Surveys or polls in which people choose whether to participate are often called self-selected or voluntary response surveys. Okay, we actually commit this when with our course evaluations. When you guys get to evaluate the course, those are optional. So the outcomes of those surveys are questionable because of participation bias. Okay, the student gets to choose whether they want to take that survey or not. And most students, they just say, I'm not fooling with that, I don't have time, and so they don't do it. And many times the students that do participate in those surveys are students that feel very strongly or very motivated to take those, okay, for different reasons. So I know when I read those, or when I read my course evaluations, I know they may not be representative of the actual class. Also, think about this. This is another example of participation bias. Can you trust the product reviews before purchasing something? So if you're like me and a lot of people, before you go out and buy something, you may read the reviews for it. Okay. Well, those reviews are optional. Okay. Those participants get to choose whether or not they leave a review. And so who is typically more likely to leave a review? A person that's really upset, or a person that really loves the product. Okay. A person that's very emotionally motivated to do so. And so all those individuals in between that are just simply maybe satisfied with the product, they're left out. Okay, so you have to be careful reading those reviews. You need to just be aware of that. It would be different if those reviews consisted of a random sample of individuals that had bought that product. Okay, that's not how they're done. All right, guideline number 4. It says, look for problems in defining or measuring the variables of interest. Okay, so first of all, what is a variable? Well, we know, or you guys, I'm sure, probably know what a variable is in the context of algebra. A variable is any item or quantity that can vary or take on different values. Okay, so the variable of interest in a statistical study is the items or quantities that the study seeks to measure. Okay, so it could be like the satisfaction level of a particular product. Okay, because when you rate those products, lots of times you use a scale of 1 through 5. Okay, or if we're trying to study, let's say, I don't know, blood pressure for middle-aged men who smoke. Well, the variable would be the actual blood pressure. It'd be a numerical measurement. All right, let's look at this example right here. It says a Roper survey of randomly selected individuals who are among the wealthiest 1% of Americans found that these people would pay an average of $487 for quote-unquote true love, $407,000 for quote great intellect, $285,000 for talent, and $259,000 for eternal youth. Okay. Now the variables in this study are difficult to define. Okay, so they were trying to see how much would the wealthiest Americans pay for these different variables here, for true love, for great intellect, for talent, etc. So how, for example, do you define true love? What does that mean? That's very abstract. Okay, and does it mean true love for a day, a lifetime, or something else? So it doesn't say. We don't know that. You'll hear lots of people say, maybe in their past they had they might refer to their true love. This person was my true love, or the person that I was maybe meant to be with. Okay, but they're not with them anymore. So, similarly, does the ability to balance a spoon in your nose constitute talent? So, what does it mean to be talented? How do we define that? So these are very vague variables, and it's very difficult to define them. The word talent, or what it means to be talented to somebody, may mean something completely different to someone else. Okay? And it says because the variables are so poorly defined, it's likely that different people interpreted them differently, which would make the survey results meaningless. Yeah. So you can't necessarily say that, most of these wealthiest 1%, they would pay around $500,000 for true love, because true love hasn't even really been defined. If it just means, spending a week with someone, or feeling like you have true love with an individual for just a week, then I'm not sure. A lot of people a lot of these wealthiest Americans would be willing to pay $500,000 for that. All right, and we'll continue. Guideline number 5, beware of confounding variables. These are also referred to as lurking variables. Okay, so these are variables that are not intended to be part of a study, make it difficult to interpret the results. And these variables are referred to as confounding or lurking because they confound the results of the study. Okay, I'm going to give you an example. And there's another link to a video right here that gives you another example. Okay, does drinking coffee cause lung cancer? And so it's interesting. Watch that video. Okay, it says, has this new supplement that I'm taking for joint pain really helped my joints? So anecdotally, guys, you'll hear a lot of people say, well, I started doing this and it really helped me. Or something really changed, or I stopped doing this and it really changed. Okay. When I hear anecdotes like that, I only half believe them, because for one thing, they're not very scientific. Okay. There's not an experiment. There's not a treatment versus a control group. There's no placebo involved. Okay. Lots of times you may hear somebody say, well, I started, let's say, well, I have trouble sleeping. So let's say, my mother, because she's a bit notorious about this, she'll say, well, I started taking magnesium and that really helped my sleep. Or you hear somebody say that. Well, maybe it did, maybe it didn't. Okay? Maybe there was something else in her lifestyle that was changed as well that wasn't actually taken into account in the study, and so that something else would be a confounding variable or a lurking variable. So for example, let's say I suffer from joint pain and I do start taking this supplement, okay? But at the same time, I'm also on this diet and I'm exercising, so I'm losing weight and I'm sleeping better at night, okay? So maybe my joints do feel better, but it's not because of the supplement. It could or could not. Maybe it was simply because I've changed my lifestyle, or there's some other confounding variable in there that's actually responsible for my joints feeling better. Or remember, it could be due to simply the placebo effect. I think when we're talking about the world of supplements, guys, it is a multi-billion-dollar industry. And so a person starts taking a supplement and they feel like they're feeling better. Well, how do we know it's due to the supplement or it's simply the placebo effect? They're taking something they feel like is going to make them feel better, and consequently they feel better. Okay, so we have to be very careful. And a lot of those supplements are not really tested by the Food and Drug Administration. They're tested in the sense that they're safe or not, safe or unsafe, but they're not really tested as to their effectiveness. Okay, so I am positive that we waste a lot of our money on supplements. Okay, now, I'm not saying supplements are bad or can't be beneficial, because I think sometimes they can. I'm just saying be careful. Okay, when you hear a lot of people that study nutrition and longevity and things of that nature, they'll say things like there is no substitute for a healthy lifestyle. And what that means is it may not be necessary to take a dozen different supplements if you are eating a very healthy diet. You're probably obtaining all those nutrients that you need, and that you are exercising adequately, and that you're getting an appropriate amount of sleep, and you're doing things that decrease your level of stress, okay? So anyway, just be careful, okay? We want to be wise consumers again, right? Let's keep going. I think I'll be able to finish this in just one video. Guideline number 6, and this is fascinating to me from a psychological perspective. Consider the setting and wording in surveys. The way the survey questions are worded can elicit different responses from the same individual. This is fascinating. Therefore, we need to word the surveys in the most unbiased way possible. And so whenever you guys are working on your statistical project, and you're conducting a survey, you want to make sure that it's free from bias. Okay? This may remind you of the appeal to emotion fallacy, or the fallacy of limited choice, right? When we ask somebody about something, but we only give them limited choices, or we somehow appeal to emotion. And this is used in politics constantly. So here's an example. It says the Republican National Committee commissioned a poll to find out whether Americans support its proposed tax cuts. So this is the way they did it. They asked, and this is the wording, do you favor a tax cut? And when they asked that, a large majority of the respondents said yes. And so therefore, should we conclude that Americans truly support the proposal? Okay. So notice here, the question was very simple. It just said, do you favor a tax cut? And ask yourself, how many people, when asked that, would actually say no? There would be some, and those people are probably individuals that are thinking about, well, what are the repercussions of a tax cut? Does that mean that I'm not going to get Social Security benefits when I get older and retire, even though I've actively paid in to Social Security? Does it mean that we're going to have to decrease spending on the military? Does it mean that we're going to have lesser quality schools, or that the roads are not going to be repaired in a prompt manner? Okay. Notice, none of that was put into this question. Okay, so a lot of people that might not favor a tax cut when it's put into context would actually answer, yes, they favor a tax cut. Okay, so this is very deceptive. And then there's another little video I'll put in there for you to watch on the wording in surveys. And here's another example in the notes. It says sometimes just the order of the words in a question can affect the outcome. And this is really interesting. It says a poll conducted in Germany asked people in two randomly selected groups one of the following two questions. So they worded it two different ways. It says, would you say that traffic contributes more or less to air pollution than industry does? And so the respondents would either say traffic or industry. Well, technically, I guess they would say yes or no, but... And then they reworded it. It's really the same question, but the order's different. They reworded it to say, would you say that industry contributes more or less to air pollution than traffic does? And they got different responses. The only difference is the order of the words traffic and industry in these two questions. But this difference dramatically changed the result. In the group that was asked the first question, 45% said traffic contributed more to air pollution, and 32% answered industry. And then in the group asked the second question, in which those two words were swapped, 24% answered traffic, and 57% answered industry. So we basically see a complete opposite in the responses here given. Okay? So this is really fascinating, and this is why. It says people are more likely to choose the item that comes first in a survey because of what psychologists call availability error, the tendency to make judgment based on what option is perceived as most available. Okay? The human psyche is fascinating, guys. Professional polling organizations take great care to avoid this problem. For example, they may pose a question with two answer choices in one order to half the people in the same sample and in the opposite order to the other half, and then they maybe average the results. Okay? So like I said, this whole idea of sampling and how sampling is done is a science unto itself. Okay? All right, let's look at guideline 7. This is one we talk about in my statistics class. I give them a discussion question related to this. It says, check that the results are presented fairly. So it says, researchers may commonly misrepresent the results of their study in order to better support their expectations. Okay, one area in which this is very common is with graphical information. So basically what's happening here is the information is not being inaccurately presented, but it's being done in a duplicitous manner, okay, or manner that can create a narrative that the researcher wants or is promoting. Okay, so for example, these two graphs right here, they both represent the same information and they do it accurately. However, hold on just a second, guys. Okay. However, because the way it's done in each of these graphs, it can paint a different picture or portray a different narrative. So the two graphs depict the same exact information. So why do they look so different? So let us zoom in. Okay. So what do these show? It says women as a percentage of all college students. So basically the percentage of women that are going to college. So look at these two graphs. They look very different, but they each portray the same information. look on the left-hand graph. The horizontal scale goes from 1910 to 2030. Same thing with the one on the right. It goes from 1910 to 2030. Okay. Well, look at the vertical axis, guys. This is the difference. The vertical axis here goes from 30% to 60%. And the vertical axis over here on the right goes from 0 to 100%. So what's happening on the left is that you're truncating part of that vertical axis. You're only showing a very small portion of it. And when you do that, that makes these changes seem very abrupt. And it makes them appear as though they have a much larger magnitude than they actually have. So see, it looks like right here from 1920 to about 1950, there was a huge decline in women that going to college. And then there was a huge increase from the years from 1950 all the way to, you know, I don't know, 2016 or whatever. But when you look at it over here, and you can see the entire axis, these changes don't look nearly as dramatic, okay? So shrinking that horizontal axis or I meant to say vertical axis. Shrinking that vertical axis or stretching that vertical axis can make these changes or trends appear much more dramatic or less dramatic, okay? Depending on what your agenda is. So this is done a lot. So you got to be careful. That's why it's important to really study a graph, guys. So, you know, you could just rely on this first graph, but if you really study it, what's happening is, you know, in 1910 to 1950, this is really only a difference of 10%, okay? And then from 1950 all the way to present, this is a difference of 30 to this, I don't know, what this maybe is 56 or 57%. Okay, so it is a difference, but it's not as great as though it appears, okay? But it is substantial. All right, let's look at one last thing. Guideline number 8, stand back and consider the conclusions. Did the study achieve its goals? Do the conclusions make sense? Typically, in every single study, there will be a conclusion drawn or an inference made about the population. Okay? Can you rule out alternative explanations for the result? This is very big. Could there have been confounding variables? Okay? If it was an experiment, was it double-blind? Was there a treatment and control group? Were those randomly chosen? If it was, you know, an observational study or a survey, look at the wording of the questions. And then finally, if the conclusions do make sense, that's when you look and see, do they have any practical significance? Okay, so if it's a robust study, then you can say, okay, what can we do with these results? How can we use these results? Okay. All right. Oh, I'll say one last thing. You know, because I try to take care of myself, because my daughter just turned 1 not long ago, so I'm an older dad, so I want to stay in good shape. So I do look at research and things on longevity and health and things of that nature, and a lot of the drugs and supplements that are promoted or marketed for longevity, they have only been tested in mice or rats. So that should be another big red flag. Okay, now mice and rats, they are mammals, but we are not mice or rats. Okay, and so there could be results obtained from mice or rats that you might not be able to obtain those same results from humans. Okay. Anyway, guys, this section is not terribly long. Okay. It's mainly conceptual. Okay. So you're, in a sense, I guess you could say you're not really doing any math because you're not doing any number crunching here. But this is we're going over these concepts. So anyway, I'll see you in section 4C. 4C is about portraying information graphically, organizing data, okay, organizing data and displaying data graphically. And the reason we want to do that is because when we have data, when we've collected data, say from our sample, we want to let it tell a story. Okay? Of course, we want that data to be coming from a sample that's representative of the population, of course. We want to let it tell us a story. And so we can do that by organizing it and then displaying it by means of a graph. Okay, so that's what we're going to talk about in 5C. So I'll see you there.